Tech Talks. I'm glad to have you here. So let's get to it, shall we? Howdy, welcome to Oogie's Tech Talks. I'm Oogie, and as usual, my friend Joseph is here with me.
Hello,
Producer
everybody.
Joe. Today, we're going to be talking about, today, we're here at M2 Antenna Systems Incorporated. And M2 makes a lot of antennas. Many different classes, many different styles. Some antennas, like the big dish reflector antennas, require a source external to the antenna. So we end up with feeds that launch into the dish. So what we do with these feed horns is we put whatever signal we want to transmit out or pick up whatever signal's coming back down, either on connectors or waveguide. Now, in this case, we have a single frequency feed. This one's designed for S-band, which is the frequency from 2 to 3 gigahertz. And this one changes the signal from an electric field that's going up and down with its orthogonal magnetic field going left and right to a circular polarity. So the electric field is actually rotating. This one's a dual polarity, so it can actually produce both a left-hand circularly polarized signal and a right-hand circularly polarized signal, depending on which port you put it into. And the same counts for this one. Now this, on the other hand, is a scalar ring dual band feed. This one has S-band on the outside, X-band on the inside. The S-band has 4 ports, which pick up one linear polarity, vertical polarity, and horizontal polarity. You can keep it linear, or you can run that into a beamforming network, which is a little assembly of electronics that takes that and derives left and right hand circular polarization from the linear ports. This one is a polarizer just like this one, which creates dual circular polarities. It's got waveguides on both sides. And that's made up of, amongst other things, a polarizer, which in this case is getting ready for paint, so it's all taped up at the moment. And then, just because we like to do it like this, a square to circular transition. And as this is getting inserted into the main cavity of the S-band feed, we just have an additional feed tube to get it to the point where it launches at the end of the scalar ring. Right there. Now, at the end of this, after everything's painted, assembled, and ready to go, we're going to put Kapton window over this and capture it, specifically to keep little flying critters out. Because as it turns out, if you get a 6-inch wasp's nest in there, you're not receiving anything anymore. And that might just bug you a little bit. Sorry, bad joke. Bad joke. One of the challenges in doing this is sometimes you need to take your signal and move it from some point to some other point. And for that we have waveguide. Now we developed this one as a direct waveguide feed, specifically for convenience and power handling, because those little coaxial cables don't always handle quite a lot of power. So, the fun thing about waveguide is that it's just hollow rectangular tubing with flanges. So you can see the waveguide port there, and you can't see it very well here, but inside there's a 45-degree cut which takes the signal and bounces it straight down the tube. The waveguide itself is literally nothing more than a hollow tube. And you can run hundreds of feet of this stuff without losing a heck of a lot of power. And it can handle a heck of a lot of power. You can put 20 kilowatts through this without a problem. Coaxial cable, only if you want to see it go poof. You know, if you like smoke, you like smelly burning plastics, go ahead, knock yourself out. Listen, this is one of the things that M2 does, and they're actually particularly proud of this, and it works very well. That's it for this one. Thank you very much for being here. We appreciate it. Any questions, Joe?
What does a scalar ring do?
The scalar ring actually does a couple of things. Anything coming in off to the side, it's set up for a quarter wave depth, quarter wave space, quarter wave step depth, quarter wave space into here. Anything coming in off to the side gets canceled. It actually knocks down the side lobe. So the stuff that's, if you're pointing a dish here, I don't want to hear anything from that tower that's over there. So that signal gets cut out. It helps attenuate it quite a bit. At the same time, moving this scalar ring relative to the launch point of the throat of the feed, moving it backwards or forwards, helps control the beam width. So we can adjust this just by loosening this, and we can take the scalar ring back, we can move the scalar ring forward, and we can control the beam width so that we illuminate that giant reflector much better. And in one of our next videos, we'll go outside and we'll take a look at this thing as mounted on the antenna so that you can see, and we'll go to the whiteboard a bit so that we can explain that focal point again and where we put the feed and why we put a feed there, or how else we can put the feed. Anything else? All right, thank you very much for being here, and everybody have a great and blessed day. Sawadee Kap. Sawadee Kap. So one of the other things that we do is we go from idea, we get a request from a friend or a customer, whatever, and they want, I'd like a C-band feed, dual circular. Well, we can do that. In the case of the X-band feed, we go from concept to a proof of concept, which we actually build just by hand out of scrap material that's just laying about, all the way to a final deliverable. Well, this one's not final yet. It's waiting to be painted. And this is a good example of origami. I just bent a bunch of sheet metal together, hand cut a septum with a nibbler, and selected the right probe lengths, measured the whole thing, and assembled the whole thing, and put a nice back reflector on it out of another piece of origami bent aluminum. And now I have a proof of concept. It's quick work to do that, and a lot of fun. Once again, thank you for being with us. Sawadee Kap. Now, one of the interesting things about M2 Antenna Incorporated is how do we get the precision machining done for the final deliverable products. As you can see, it's a fully staffed and equipped machine shop with a bunch of brilliant mechanical engineers, machinists, and it's a lot of fun. We make all the parts in-house. This is how we can keep production times down. Hey, thank you once again for being here with us. Thank you for attending. It's always fun, and it's always a pleasure and honor to be talking to you. Sawadee Kap.